Hey, good morning, fourth grade. So, I'm really excited for today. We have a lot of great things coming our way. So, we've been talking about the Grand Canyon National Park. And so, with that, before we get started, I want to take a look at some work from Friday's short response, not yesterday's classwork, but Friday's classwork. So, we had to pick this claim for what happened to the dinosaurs, right? And so you had the choice between a killer asteroid or a volcano, but it was your opinion would which one you thought was the best argument. So this scholar, who was actually in Penn State, shout out to Penn State, um, chose the killer asteroid. You may or may not agree. So let's take a look at this scholar's work, and then we'll figure out what is really great and then what we would fix for what I'm looking for, because this is pretty much what I'm looking for. So killer asteroids give a good argument because it talks about why does it impact the how the dinosaurs died. Okay. Um Now, on page 11, it says that the asteroid that hit Earth killed the dinosaurs and changed Earth's features. Also, on page 14, people are arguing if the asteroid or the volcano eruption caused the dinosaurs to extinct. So, I want to really focus in on the evidence here, right? So, that's what the question was asking for. I think the first piece of evidence is really strong, and I love how this scholar used a specific page and a specific line from the text to do that. So, I think their first piece of evidence is spot on to support the killer asteroid. However, the second piece of evidence is a little bit, it could be more specific because it's kind of just explaining that the asteroid or the volcano caused the dinosaurs to extinct. We want to still focus on just the asteroid. So, this was great work, but we want to make sure that we are staying having those two specific pieces of evidence from our textbook to support our idea. But the reason why I did put this scholar's work up there is because this scholar made sure that they went one into the textbook, and tried to give two specific pieces of evidence. This will, if we're doing a short response, we need to make sure that we're going back into the text. Yes, we have a lot of personal experience and stuff in our brains that we think, but we also need to support it with facts. Cool beans? Cool beans. Thanks to that Penn State friend. So, we've been talking about the Grand Canyon National Park, and we've been talking about the Desert Rocks National Canyon this for a while now, right? And today we're actually going to be talking about Keller's Canyon, which is a little bit further down in the Grand Canyon National Park. So, but they have some similarities. So I'll give you a second to look at both of these canyons and think about what is similar and what's different. So they do have some similarities. So yes, there is still pieces of body of water in between both, but then here it looks like there's more exposed layers. So we'll get to we'll come back to that in a second. Those exposed layers in this Desert Rocks Canyon. So we've investigated how rocks build up in layers over time. We've talked about how we have our oldest layer at the bottom, and then as time has gone by, we have those newer, younger layers on top. And from there, we have our youngest layer at the top. So pretend that we're this person, this orange little guy up top of all these rock layers. Now, personally, if we're standing on top of this cup, we don't see any exposed layers. We're not able to see that there are rock layers below us because there isn't anything exposed. If we look down, we're standing inside the cup. We can't see that there's other layers. We only see the layer that we're on, the surface, right? But there are other layers below. We have to wait for something to happen to expose those layers, whether it's like a crack, whether it's like something that's exposing the other layers to us at the surface. So let's take a look here. We have again our Desert Rocks Canyon and we have Keller's Canyon. Now we were talking about, I know I told you earlier, like, hey, there are some similarities and there are some differences. Now, I said earlier that like it looked like there was more exposed layers for the Desert Rock Canyon. We can take a look real quick. There's more exposed layers here than there is here. There could be more layers underneath, but it's just not exposed. We don't know as of yet. But from here, from data, we can know that the depth between the canyon and the water is about 1,000 meters. And we have, for the Kellers, there's the depth between the top or the youngest layer to the end of the exposed rock is only about 500 meters. So there's fewer layers exposed here than there are for the Desert Rocks Canyon. Now, I wonder why that is. Well, the only thing I can really think about right now, just based upon what we're looking at right here, is that the amount of water that's there. Maybe the water has something to do with it. Let's keep that in our back pocket as we continue the lesson. So the big question that we're going to try to get to today is, how do fossils and other rock layers get uncovered or get exposed? So we have this Rocky Wonders map. And we have this, geologists use this map for many different reasons. In this case, it's telling you where these natural hazards, such as rivers or earthquakes or volcanoes, are happening in the United States near these canyons, right? So we have this Black Canyon, which is very similar to our Keller Canyon that we're going to be talking about today. But this one is on our map. And I'm going to give you a second to try to figure out what could affect or what could have been forming this canyon. I'll give you a hint. Look at our key. Okay, and bring it back, and bring it back. Okay, so if we're looking at this, we can see that around the Black Canyon, there's a bunch of these purple little circles, and there's a few of these little triangles. So I know that around these Black Canyons that there has to be a lot of earthquakes. But wait, okay, Miss Clark, how did you know that? Oh, okay, I said all these purple little dots were around here, all around it. I go back to my key, and it says that those purple dots mean that there are earthquakes. So did I just say that the earthquakes are the reason why the canyons happen? I don't know. That's a possibility, but I'm not too sure. There's a chance that it could be another reason why. Okay, but let's keep that in mind. That map just told us that there are a lot of earthquakes happening. I know when an earthquake happens, the earth shakes and that there are a lot of effects to it, but can it actually make a whole canyon happen? Interesting thought to keep. So what we're actually going to be doing today is we're going to be reading Rocky Wonders. I'm going to be reading a little bit for us and get us started, and then I'm going to send you off to be reading a little bit on your own. But what I want you to be thinking about as we read, when I'm reading myself or when you're reading out loud to either yourself or to your pet or to your sibling or to an adult that's in your house, how are these rocks formed? Okay. So, when you see a tall cliff or a huge boulder, it might be hard to imagine that it could ever break into smaller pieces. Rocks are stable and never change, right? Guess again. Some of the most interesting wonders of the world are formed when rock is worn down over time. This process can create rocky outcrops so beautiful and strange they'll make your jaw drop. That's true. When rock, soil, or sand is worn down over time and moved from one place to another, we say erosion is happening. That word erosion, I'm not really too sure what it means. Oh, I'm going to keep reading. What could possibly erode rocky outcrops, which seem so unstable? Let's explore some rocky wonders around the world to find out what can make them change. So wait, let me go back to this word erosion. And I didn't just stop reading and give up and try to figure out what that word meant when I don't know what it means, right? So I kept reading, and then it says what possibly could erode rocky outcrops. So that's another version of erosion, erode. And if I'm thinking about, just because in this part of the text it doesn't say what it means, doesn't mean that this whole introduction doesn't tell me what it means, right? So if I'm thinking about erode rocky outcrops, so when they were talking about rocky outcrops before, right, It's saying some of the most interesting wonders of the world are formed when rock is worn down over time. Okay, so that has to be something with what erosion means. When rock is worn down over time, that means that rock isn't always the same. Something's causing it to change. So this process can create rocky outcrops so beautiful and strange they'll make your jaw drop. So then I'm also looking at these pictures, and they're telling me that they didn't always look like this. So that has to do something to do with what that word means. Well, oh, here we go. The word erosion. What's the word? Okay, now what does it mean? When rock, soil, or sand is worn down and moved from one place to another by water, wind, or ice. That kind of goes back to what I was talking about over here. When rock is worn down, okay, that was giving me some type of clues of what that word meant. Don't forget, that skills you're learning in ELA, you can also be using it in science as well. So wait. Hold up. When we have a new vocabulary word, I know that there's some of you that are writing this right now. You guys are rock stars. And if you're not, I also want you to make sure that you're reminding yourself what this word means. So what's the word? I hope you're all saying erosion. Okay. And what does that word mean? When rock, soil, or sand is worn down and moved from one place to another by water, winds, or ice. I kind of just made some hand movements of like some water happening, like some waves, and then some wind, like moving my arms all over the place, and some ice, like kind of like my hands pounding together pretty hard ice. So let's keep reading. White Desert, Egypt. The White Desert is exactly what it sounds like, a desert made of white sand and rocks. It also has some enormous white rocky outcrops. The White Desert is famous for white columns of rock that look like giant mushrooms. They do look like mushrooms. The white columns are made of a type of rock called chalk. It's the same material that people use to write on sidewalks and chalkboards. Chalk is softer than many other kinds of rock. That means it's not as stable as other types of rock. Well, that was really helpful when I was in school, because when I was in school, we didn't have whiteboards and we didn't have these, the projectors for us to write on and stuff like that. We had whiteboards and we had chalkboards with chalk, and that was it. So that's something that was very helpful when I was in school. What could have turned a rock layer into a strange white rock formations we see today? Wind. Imagine a sandy beach on a windy day. The grains of sand are tiny enough to be picked up for a few moments by a strong wind. The sand grains are only lifted a little way off the ground. They can bounce into a solid rock before they come to rest on the ground again. That's how rocky outcrops in the White Desert formed. Sand is a type of sediment. Every time the sediment hits a rock, tiny pieces come off the rock. Over millions of years, huge parts of rocks chip away. The parts of the rock that are closer to the ground get eroded more quickly since all the sediment is bouncing around close to the ground. That's why many rocks in the White Deserts are shaped like mushrooms. So now, don't forget, that question we were thinking about in our head while we were reading is, how did the rocks form? So how did the rocks form for rocks in this White Desert in Egypt? If you're thinking wind, ding, 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 you're right. So again, we can prove this by going back into the text and figuring out some evidence. So it's talking about pretty much in this page, it goes into that a little bit more. The grains of sand are tiny enough to be picked up a few moments by a strong wind. The sand grains are only lifted a little way off the ground. They can bounce into a solid rock before they come to rest on the ground again. Okay, that's some evidence right here about what happens, that the wind, now I'm explaining my evidence, which is super important. The wind takes off the sand grain, takes off of the rock, and then it off onto the ground. And then that bounces into a solid rock before they can rest on the ground again. But I think we can also, and it also shows that over here, them hitting, going from the wind direction, hitting onto this rock. But then why does it have this shape? Let's keep reading. That's how the rocky outcrops in the White Desert form. Sand is a type of sediment. That's not the best evidence. Every time sediment hits a rock, tiny pieces come off the rock. Ooh, this is sounding like it's getting to it. Okay. So over millions of years, huge parts of rock chip away. Okay, that's still going into it. The parts of the rock that are closer to the ground get eroded more quickly since all the sediment is bouncing around close to the ground. That's why many rocks in the White Desert are shaped like mushrooms. So this whole part of from every time sediment hits a rock all the way to when it's talking about close to the ground, like that whole section up to here is really great evidence in support of how that rock formed. Actually, all the way to the end of the paragraph is showing how the rock formed and why it's shaped like this. Because these lower ones over here are the most erosions happening. So it's not affecting as much up here. It's still affecting it, but it's still affecting it more down here. Hazard warning. The White Desert is a popular place for tourists to visit. People like to hike and camp there. However, it's very dry and hot there. The average amount of rainfall is less than 1 centimeter per year. The hottest days can get up to 48 degrees Celsius. That's hot. It's easy to get dehydrated and overheated in this kind of hot, dry weather. That can be very dangerous. In order to stay safe and healthy, people should check the weather report and stay inside on the hottest days. The local residents have built houses that stay cool inside even on the hottest days. People who are going out in the desert should wear clothing to protect them from the sun and carry plenty of water. And then the White Desert looks like it's covered in snow. That's actually rock. It's too hot and dry for snow in the White Desert. It does look like snow. But this page wasn't super important to showing how the rock was formed. It did just give us some really good information about what it is like in the White Desert, and also showing that it could definitely 48 degrees Celsius or 118 degrees Fahrenheit. That's like a very, 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 very hot summer day here. Like it doesn't usually get that hot here, but in where this desert is, it's extremely hot. So there's no way that this could be snow. It is sand, and is the wind is what is forming the erosion and the rock to form. So now going back to this, as you continue to read, you're going to be starting to talk about, you actually read about this Black Canyon. And we did say it was earthquakes that I was thinking in my brain. It could be earthquakes that formed the rock, but maybe not. So you're going to continue reading and you're going to think about these Black Canyons that you're going to start reading about in a couple other places that have similar rock formation because of different things. And you're going to read about those. And then we're going to come back tomorrow and we're going to talk about it and think about, hey, was that right? Was it really the earthquakes? And I bet you, I'll give you a little hint. Bet you that's going to be part of your exit ticket today. Cool. So please make sure that you are reading your text, that you are going back to give evidence when you are asked to, because I will be saying you need to give evidence. But here's the thing. I'm going to actually be looking for some friends that are going to be giving me really great work. And because I want to spotlight some friends' work tomorrow in the beginning of our PowerPoint, give them shout outs with their names. I'll even ask them, hey, do you mind if I put your work out there tomorrow? Hopefully they'll say yes. And hopefully you're still listening, because then you'll know, hey, Miss Clark is really looking for some friends to put up on this PowerPoint tomorrow and show some spotlight. Rock stars are still listening. I know you are. So good luck today. If you need help, reach out. But remember, read that text. Read the book. Read the textbook. And give your evidence. Cool beans? Cool beans. And you're off. Till next time.